Right, talking about a really tough topic, which is about bracing the walls. So I've got a wall here that's 3 meters across, and it's 2.4 meters up until you reach the ceiling. Now, when we draw braces, we need to actually get the brace to keep the wall stable, and it has to always go from the floor to the ceiling. And the longest brace we can make is from corner to corner. So that's what we try to do first of all. Now, the important thing about bracing is that you have to worry about this angle down here. The angle the brace makes to the floor has to be within industry standard. It means there's a rule that you say, okay, we can have a brace, but it has to be in these angles to the floor. And that industry standard is between 37 degrees and 53 degrees. Bit of a dodgy 3 there. I'll do that one again. Alright, so that's our industry standard we always have to meet. So the tough thing is that we need to think about some trigonometry now, and we know we've got a right angle triangle here. So our triangle we're actually working with looks like this. Here's our theta, we have 3 and we have 2.4. Now our steps of our trigonometry are always the same. So we have draw our diagram, label up our sides, and then we can figure out what we need to do. So let's label our sides. This is our adjacent side, this is our opposite side. Let's write out the information that we know now. We've got opposite equals 2.4, adjacent equals 3, and what we're trying to find is theta. Right, we don't know what that one is yet. We need to look at what rule we are going to choose. So the rule we are going to choose has to have O and an A in it, and let's look at our SOHCAHTOA. And if we look at that, we know we have to actually pick a rule that has the O and the A in it, and that's this one over here, which is tan. So we're going to start our working out like that. Tan of theta equals O over A. Now we've got the O and we've got the A, but what we don't have is the theta. When we need to find our angles, we need to find only the angle, we get to use our inverse trigonometry rule. So theta equals the inverse tan of O over A. We can substitute our values in now because we know what they are. So the inverse tan of 2.4 divided by 3, and our answer is about 39 degrees. So you need to check, does that meet the standard I need to fit? Here's our standard. Does 39 fit into that category? Yes, it does. Excellent. Now we might want to be able to find out how long the brace actually is. We've found it fits in industry standard with the angle. Now we want to know how big it is so I can buy that amount of wood. So we'll clear this one up and we'll draw up our wall again. And here's our brace. Oops, not great. We know that this angle here is 39. It's all good. 3 and 2.4 meters. But what we want to find out now is how long this brace actually is. So we'll go back to working with our right angle triangle. And our right angle here is this, and here it is. We know this is 39, 3, 2.4. And we'll label up our sides this time. So our sides are labelled opposite, adjacent, and hypotenuse. What we're trying to do is find the hypotenuse. And a rule with a H in it is going to be our sine rule. So we're going to use sine of theta equals opposite over hypotenuse. So we've got our opposite side, we've got our hypotenuse, and we've got theta. Sine of 39 equals 2.4 divided by our H. We don't know what that is yet. When it's on the bottom though, we know we've got to do a quick switcheroo, and these two have to change over. So we are going to switch them around to have H equals 2.4 divided by a sine of 39, And when you put that into your calculator, you get 3.8 meters. So it's telling you that this brace, that is industry standard, it's all good, it is going to be 3.8 meters long.